morning, everyone. My name is Marc Godin. I'm pleased to be moderating this session today for CRIN, the Clean Resource Innovation Network. It's the Project Cafe, and it's part of a series going through the months of May and June to report back to our network on the accomplishments of the various projects that are funded by CRIN. Today, it's about digital technologies. Welcome. It's a great day in Calgary, the audience here in Calgary, but also hopefully across Canada for all you folks online. First start with a few words of logistics and then turn it over quickly to our presenters. In the spirit of reconciliation, we acknowledge that we live, work, and play on the traditional territories of the Blackfoot Confederacy, the Siksika, Kainai, and Piikani, the Tsuut'ina, the Stoney Nakoda Nations, the Métis Nation Region 3, and all the people who make their homes in the Treaty 7 region of Southern Alberta. We also acknowledge that our participants are across Canada and the United States, and please take a moment to acknowledge the lands on which you occupy. So this morning, we have 7 presenters inside the 1 hour allocated to this event. So they will be fairly rapid fire, 5 minutes each, and then we will do question and answers at the end. So we encourage you to note your questions, whether you're in the audience here, we'll have a microphone, or online, use the functionality of the system online to write your questions as they come to your mind. And it's my pleasure to introduce the first speaker from Kuva Systems, Monica Sippola, and she will address machine learning for false positive elimination in continuous methane emissions reductions. Welcome, Monica.
Well, good morning, everyone. Really pleased to be here. So thank you to CRIN, not only for creating this event, an opportunity to share about our projects and technologies, but of course, for your support to help innovation in this sector. So thank you. My name is Monica Sippola, and I'm the Director of Business Development with Kuva Systems. And I'm here to tell you about what we've been up to. Just need to advance correctly. There we go. And so all of us here today are going to be just giving you an overview about the project objectives and our progress thus far, and some challenges that we might have encountered along the way. That's what happens, right? And along with an invitation for some collaboration opportunities. And so we know that methane emissions are a significant issue for the oil and gas industry to address right now. They're just under increasing pressure to deal with them. And studies have shown that really it's about 70% of methane emissions in the oil and gas industry are highly episodic in nature. And these larger emission events that are known as super emitters, they tend to be very intermittent, and those are created by equipment like control tanks, compressors, and unlit flares. And those are notoriously challenging to monitor. And so where there could be an aerial flyover one day, the next day, more than 50% can't be found the next day. And so really what's needed is eyes on the ground, visual continuous monitoring to allow for that fast detection and repair, which will ultimately help reduce more emissions. And so here's a preview of what we do at Kuva, where we deliver visual alarms as a GIF clip. And here's a couple of examples in particular about addressing tank top emissions, which can be highly intermittent, and as well as we're able to monitor unlit or underperforming flares. And so how do we do it? Well, we have our own proprietary shortwave infrared camera that we've developed, and we pair that with our Kuva Cloud for the monitoring and reporting of emissions events. And as we've been talking to with the oil and gas industry, we just hear that it's so important to have no false alarms for them, because with false alarms, that creates a sense of it erodes trust and confidence in the monitoring system, as well as ultimately it's a cost issue. And so that's a key element for us to be able to deliver no false positives. And our CRIN project is supporting the further automation of this with machine learning for false positive elimination. And we're really pleased to have great partners like Synovus and Whitecap, where they are our site hosts. We've installed at their sites about half a dozen sites each per company, and where we're monitoring for and gathering data. And then have partnered with AMI, the Alberta Machine Intelligence Institute, for the development of our ML model. And so our progress to date thus far, I'm pleased to say that we are on track to complete our project by the end of this year. And just briefly, in terms of the first element, was basically to be getting ready for the machine learning element. And that's an element of data labeling. We have highly unstructured image-based data that needed a good amount of structuring and data and labeling to prepare that for pairing with the machine learning model. And we're really pleased that by pairing with Amy, that they were able to understand and grasp what our image-based data required in the machine learning model, and they've been a great partner for us thus far. Next steps are just to continue with the integration of that, and then ultimately to be able to deploy this new model at our sites in Alberta. And so just a couple of lessons learned or challenges. First of all, the data labeling exercise is quite significant in that it takes longer than what we had anticipated, just in terms of labeling that sufficient volume of data, and as well as the speed of that. And especially as we grow to scale, that's something that we want to be able to address now. And secondly, we're monitoring on a wide variety of scenes. And so as we're monitoring for the image-based, with our image-based data, then we need to be able to develop consistency within our machine learning model. And so our team has just been focused on labeling more of that training data for the ML model to be able to optimize that for different scenes. And so collaboration, we are really pleased with the collaboration that we've had thus far with Amy. It's been very successful and really, frankly, has exceeded expectations for us, not only on the project schedule, but just the ability to be working with them, and really appreciate how they've been able to understand what we've needed, and just be able to creatively present new ideas and develop the fluency in what our needs were. And then secondly, from a collaboration perspective, consider this an invitation for all the oil and gas operators, and that it's an opportunity to be able to reduce your methane emissions. And with the camera-based visual continuous monitoring that we provide, that helps operators be able to understand the root causes of your emissions, and then ultimately to help prepare for incoming regulations. And so our next steps are to continue on with our project timeline, as well as collaboration with Amy, and continue to enable oil and gas operators with ultimately improving their operations and reducing methane emissions to be able to help them see their emissions to solve them. Thank you.
Thank you, Monica. And it's been my pleasure to follow Kuva and support Kuva for the last 5 years. And Monica, we had you in Houston at Trade Mission and at the Methane Summit a couple of weeks ago. And same with Qube. I remember speaking with Alex McGregor 3 or 4 years ago, just a prototype, and now a fabulous company that's grown tremendously. So I'm pleased to introduce Taryn Humphreys of Qube Technologies, and she will speak about emissions reduction through continuous monitoring and artificial intelligence. Taryn.
Hi, good morning. First of all, thank you to CRIN for hosting this event and for the ongoing support throughout our project. We've been really excited to be working with our project partners as well as CRIN. My name is Taryn Humphreys. I'm the Director of Business Development with Qube Technologies. I'll be speaking to you today about our project, which is emissions reduction through continuous monitoring and artificial intelligence. Talk a little bit about our project objectives, what we've achieved to date, some of the challenges we've encountered, some of the ongoing collaboration opportunities and integration that we've had, as well as next steps as we proceed with our project. So our project objective, what we wanted to do was evaluate the use of a low-cost continuous monitoring system to be able to use as an alternative leak detection and repair for ultimately emissions reduction and reducing environmental impact. And so having the ability to have site level integration with using our artificial intelligence to be able to localize where leaks are occurring and quantify those leaks and understand, what's truly happening on site allows our clients to be able to have actionable insights in real time. We know that emissions are intermittent in nature. And so having the continuous monitoring to be able to understand when they're occurring, not necessarily when they're surveyed, months or even years, depending on the frequency that's typical with the current directive or current regulations, that helps to be able to reduce those in real time. And then that allows our project participants to focus their ESG efforts and really truly understand using the analytics that we're providing and using better data to be able to inform their decisions. So progress to date, we have 2 project partners. We're working with Arc Resources and Loyal Energy. We had our deployments last summer. So we set up, you see on the right, we call these our Axon devices. These are using fixed metal oxide sensors, and they are set up around the perimeter of a facility. We're also then monitoring environmental conditions, so wind speed, wind direction, temperature, pressure, and humidity. We're aggregating all that data. These collect data every 3 to 5 seconds, 24/7. So we're running all day at these sites and aggregating all of that data. We send that to our cloud, where the cloud is then using physics-based models to understand, where truly the leaks are happening, so the localization on site, and then using a Gaussian plume model to actually determine a site rate and be able to understand, what truly the impact of these emissions are. And so each site has to be baselined. We need to understand what's the background at each one of these sites. We set up a dashboard. I've got a little clip further on here to show that. And then we have an adjustment of the emitting sources. So for companies to understand what may be emitting, is it tanks, flares, compressors, what are the likely emitting sources, to be able to pinpoint those and then take action to reduce those emissions as we see them. So we're ongoing. We've had our not quite a full year of continuous monitoring. We'll be continuing with another year beyond that. Not only are we doing the emissions, but we're also really building out our models in the background with all of our data science team. So working on those algorithms to better understand and report on the emissions. And then we've also been able to establish all the site level alarms. So that's truly a big step to understand, what are the big events that are happening? Are there emissions events that need to be acted on in a rapid manner that can ultimately reduce emissions? So progress to date, scrub total volumes here, but just one of our operator sites, all of their sites actually in aggregate, we've seen a 68% reduction over time from August 2022 to March 2023. This is pretty significant. You can just see that downward trend there. On the right, we just have an example of the dashboard setup that we have. You can see site equipment. It creates a heat map, so you can understand when an emission event is happening, where is it localizing to? And then from there, we produce a site rate and total volume as an emission volume. So this is a really great step progress that we've made throughout this project. So some of the challenges, we have had project team member changes with the operator companies that we're working with. So that's delayed a little bit of the time that we've had to build out the operational workflow. We really need that operational engagement and truly understanding, when an emission event is occurring, when the alarm is exceeded, how are we acting on that to send a crew out to be able to check for those and repair those emissions. So having that operational engagement has been really critical. So that's taken a little bit longer than we were anticipating. And then just being able to have the site prioritization. We know that ultimately there's often a few leaks that lead to the highest amount of emissions. It's kind of that 80-20 rule. 20% of your leaks are a result of your 80% of your emissions. So focusing on those and being able to drill down into the specific equipment group to understand the root cause and then affect your operational efficiency to reduce those emission events going forward has been really key. So collaboration opportunities, we've established our user group meetings. One of our project partners is a participant in this. This allows them to understand and work with some of our other clients as we build out these workflows. This is fairly new. The concept of a metal oxide sensor isn't new, but the use of that to turn that into a localized and quantified site rate is. And so building out that workflow and having some of that collaboration amongst other companies has been really key for a lot of our users. And then having integration as well. We participate in programs down at METEC, down in Colorado, as well as Qube has our own controlled release test facility. And we use that to be doing blinded, double-blinded testing that helps us to improve our algorithms, both on the localization and quantification efforts that we have and our models. And so that's been a big piece of the collaboration throughout this project as well. Next step, so we're going to be continuing with our site level reviews with our project partners, drilling into these emission events, doing some site trending, understanding really what the equipment groups are that are leading to the highest amount of emissions, and being able to have that real-time identification of leaks. That's going to be ongoing throughout the project. And then just that analysis for those companies to have actionable insights to continue to reduce these. We've seen a great effort so far under the project that we've had, and we've got a lot more to go. And then also continuing with the integration of data. So as we integrate with the producer data, SCADA data, production data, to have a better site level understanding, that's going to be key going forward as well. We're really excited to be working on this project. We look forward to future advancements and progress. And thanks very much for your time.
Thank you, Taryn. Next is SensorUp. What does it say about SensorUp? Coming out of the University of Calgary 10 years ago, amazing journey, ever optimistic, energetic Steve Liang. But today we have Jack Bogart, who will provide us with an update on artificial intelligence-driven, IoT-connected worker solutions for better safety, productivity, and environmental performance. Welcome, Jack.
Good morning, everybody. Super happy to be here. See some real humans, real clicker and free coffee. Thank you, CRIN. I'm standing in for Dr. Liang, who has established this company as a CTO. He's traveling today, going to Taiwan to present to one of the universities there. All right, SensorUp, we're all about IoT data. We're a SaaS solution. We're all about collecting information from various sources, ground, flyby, satellite, and then connecting people to be able to do their work, whether it's reacting to field issues or scheduled maintenance work. We have the solution where connects field workers and back office stuff. So on the back end. On the back office side, we have a dashboard where people can define the actions that will be performed to manage various incidents and schedule work, create workflows, and then that job, those tasks are being dispatched to field officers. And those typically work with mobile devices like phones and tablets. We also have wearables like watches to monitor safety information, like, let's say, heartbeat, for example, if somebody falls down and gets hurt, and then we react to it. So we're, like, as I mentioned, mission control on the back office, Outpost, or all those apps that are deployed to the Android and iOS, and data that powers all of this. So what's the progress to date? We're increasing connectivity to various data sources. We have done already from the site sensors to third-party integrations with SAP and Qube, for example, as well as cloud-based services. We're testing in field. We have partnerships with various companies. Work is being dispatched and monitored. We have two verticals. One is more geared towards oil and gas, so leak detection and repair, and the other one a little bit geared towards construction. So working with Powell and doing a little bit of interesting stuff with them in terms of artificial intelligence recognition of various components on sites, driving by and counting concrete blocks, for example, their cars, units, trucks. In terms of lessons learned and challenges, there are several classes of challenges. Some are technical, getting data that looks good, quality data. Sometimes things are not great. Frequency of those updates is important. And then human class of problems, people get used to their interfaces. It's a little hard to have them migrate from one solution to another. So sometimes you end up in a hybrid situation where our systems are used and a little bit of their systems are used, and then we have to reconcile the data. Data privacy is also a challenge. We're collecting information from watches and phones. A lot of people are using apps, Facebook, what have you, Twitter, TikTok. So we have to be very careful about what we collect and when, right? So they get to the site, so we start collecting information, and they leave the site, we stop. Yeah, so that's more or less what we do. And if anybody has any questions about Eldar program, happy to talk to you about it. Thank you.
Thank you, Jack. Thank you for keeping us on time. And next is Ling Bai of VL Energy. I had the pleasure of working with Ling for the last 2-3 years. It's an amazing technology, amazing company. And she will speak about field demonstration of artificial intelligence powered predictive emissions monitoring systems. It goes by the acronym of PEMSs. Ling.
Thank you, Mark. My name is Ling. Thank you for the opportunity that CRIN is hosting this for us to provide a project update. Happy to be here, and thank you for everybody to come. And as Mark introduced, we started a PEMSs project. It's a predictive emission monitoring system using AI. Sorry. Okay, so today we are going to talk about the project objectives, the progress to date, the challenges or the lessons learned from this project, and collaboration opportunities, and what are the next steps for our company as well. So first of all, what is PEMSs? So PEMSs is actually a supporting or backup tool. It's a regulatory compliance tool to replace or backup for continuous emission monitoring system, which is a physical equipment. So like I mentioned, this technology is an AI model, machine learning model as a backup. So the problem we are trying to resolve here is accurately monitoring and managing emissions from industrial facilities. So lots of the engines or the equipment are required to be continuously monitored by regulations. So provincially, we are regulated by the AEP and the AER. So the AEP is the Alberta Environmental Parks, and the AER is Environmental Energy Regulator. So what are we doing right now? Traditional approaches are one of them, the continuous emission monitoring system as a physical equipment on the site. And if they are not required to have a continuous emission monitoring system, what people do is to periodically, manually measure the emissions. And the limitation for that is, first of all, very time consuming and expensive, and it's lots of errors, and it's not able to capture the dynamic from, for example, seasonal variance and everything. So the solution is here as a predictive emission monitoring system using AI. We are able to resolve the issues that's mentioned. So progress to date, where are we sitting right now? CRIN project was awarded on January 2022. And previously, we've successfully completed one pilot through OTSG. And for this project, what we are doing is another type of equipment, which is a cogen. Then last year, August 2022, we've successfully sold our first commercial unit. And lots of tractions for sure, and we really appreciate that. And successful project spotlight from PTAC January 2023, earlier this year. And we want to acknowledge our project partner, Suncor, that our model is proven and we are moving forward with the full expansion for the full deployment in an operational setting. So challenges we entered or lessons and learn is actually very valuable. We really appreciate the opportunity. So we realize the data quality and quantity are really affecting the accuracy of PEMS because our PEMS is a regulatory compliance tool. We do have requirements, how many hours of data or the data size that we are using, and as a minimal. So we don't have a maximum. So we've been trying to analyze the differences and what works the best from technical point of view, the data size or the quantity and quality that we are using to ensure the assured quality of the data. That's been a challenge and good lessons and learn. And the second one is to integrate PEMS with the existing system. So every company is different. Companies are using the cloud. Companies are using their DCS, their local control system or central control system, which are different. It's been challenging for us to figure that out with all the stakeholders, which is the next one, stakeholders engagement. We find is very essential. It's important to involve all the participants or stakeholders at early stage to identify what's needed really for everybody who are using this tool in the company. And so analyzing, visualizing the data is really helpful because when we are talking about PEMS, we know it's a predictive emission monitoring system. But before we show that so we didn't realize at the beginning or the early stage is we are talking about this and people seems like to understand, but they really don't. So then we proceeded building a Power BI dashboard. It really helped, and all the stakeholders are finally aligning. So that's significant lessons and learn. Standardization can improve the accuracy and reliability. That's another finding that we lessons and learn from this project, which is very useful. Collaboration opportunities, we've been working with, because we are a regulatory compliance tool, so we've been engaging with the regulators, and we are looking for partnership with the regulatory agencies to ensure PEMS compliance with emission monitoring system regulation. We want to make sure we are contributing on that. Collaboration with more industrial partners, integrating PEMS with the existing system and data formats will help us keep our continuous improvement for this product. And collaboration with manufacturer, we've been in touch with a couple of them. Thank you for PTAC. And we actually got approached from being a PTAC member and CRIN member. So, and collaboration with maintenance and calibration companies to ensure ongoing maintenance, because that's not really our specialty at this moment. It's important for us to grow. The last slide. So what are the next steps? So we are considering working on scaling up. So other industrial partners who are interested, please feel free to contact us. Information available. Continuous improvement, like I mentioned, we are looking to do that. That's our next step. We'll keep doing it. And standard development, as part of CRIN, we are going to be delivering a framework at the end of the project. So we've been working on that, including all the lessons and learns and useful experience. And the partnership, we are, like I mentioned, seeking for partnership with industry partners, regulators, and other stakeholders to increase the adoption rate of our technology. Outreaching, education, and research and development are always something that we are going to do as an innovative technology. That's it. Thank you very much for listening.
Thank you, Ling. So up to now, all our presenters came from this side of the stage. The next three will come through the wires behind this screen. They're coming online. And our next presentation is from Arian Analytics with Jordan Chikoria. And Jordan will be speaking, when he arrives, about automated wildlife detection and ROBIRD, which is a drone ornithopter deterrent system. And there's a 7-letter acronym, which I won't try to pronounce. And I'm assuming Jordan will be there imminently.
Can you hear me?
Yes, we can hear you. Go ahead.
Okay,
Thank
perfect.
you, Jordan.
Hello, everyone. And sorry, I can't be there in person today. I'm actually down in Denver at another conference. That acronym you didn't want to pronounce, we affectionately call it word nerds. So our team and myself are working on the process, and it's been great to see what everyone else is doing and how these projects are going, and really appreciate it from CRIN to showcase it. So just like everyone else you've seen today, a bit of an agenda. And our project objectives are relatively straightforward. I mean, we're leveraging our drone technology as well as the creation of an automated tracking network to reduce impacts of birds and tailings ponds in the oil sands. We've all seen and heard that there have been some challenges lately, and these new advanced technologies are really there to help assist in that, to help prevent birds from even coming near the areas and moving into a more active process. I'm going to shift screens for a brief moment here. So for anyone who hasn't seen this yet, sorry, bear with me for a second here. It just paused on me. All right. I'm going to bypass that because for some reason the video is not playing. So I'll keep moving on and we'll go from there. So sorry, everybody. So the impacts have been pretty documented, and ROBIRD's actually been having some really great success in doing that. Our progress to date, the whole idea was we were doing this in twofold. It was enhanced improvements to drone technology, as well as the creation of that sensor installation and the ML design. So progress to date, we did get a little bit of a slower start on the sensor integration because of the identification of avian radar as actually going to be an incredibly great tool for us to leverage and work with. So we're working on some collaboration right now to integrate that into our process. We've been having some fantastic support with the U of A interns engaged and have really established and created the architecture for the model advancement, which has been super important on that side. On the other side, with ROBIRD itself, there's been some great improvements. We're actually ahead of schedule in advancement on our flight controller improvements. Currently, ROBIRD is piloted, but as we move towards automation, that integration with ground control stations, the ability to then take an API and move it to allow ROBIRD to fly itself has been an important step that has actually been able to advance fairly well. We've also been able to increase those takeoff and landing improvements, which is an important step towards this tool being able to automate itself. And then obviously the effectiveness that we've been seeing, we've been able to help reduce specific bird species counts in the tailings in oil sands locations, which has been showing the efficacy of new technologies and how that's working. So successes and challenges, as kind of mentioned, the flight improvements are ahead of schedule. We have identified some collaborative partners on the complementary technology, aka the avian radar side, and that results in decreasing the bird incidences has been a huge success in the first few months of this project. The challenges are milestone one, like I had mentioned, was delayed due to the identification of that alternate technology, and then just working on collaboration and integration has taken a lot longer than we had expected, and that's put us on the back foot. But I think I'm actually down here meeting with one of the companies, and once that gets moving, it's going to move us forward a lot quicker. We have had some challenges with labeling the bird species in real world applications. So again, there's a lot of databases out there of birds, but having them in those sorts of settings between shadowing, movement, those sorts of things has been a bit of a challenge for our developers, but we've been able to make some really good progress on that. Collaboration opportunities. that opportunity I was talking about with the radar and integration of those systems, I know that there's a lot of operators out there right now that do have some of these systems. We'd love to talk further about potentially leveraging some of that existing data to make sure that how we're creating the API for the movement and automated flight for Robird would be great. Just mentioned earlier as well, additional tests and trials are always important. So the more that we can get real world data on this would be great. Integration with the University of Alberta and integration with Imperial, who has allowed us onto their site for the last few years, has been fantastic. And that's continuing to show its success and moving from there. And then what are we doing next and where are we going? So like I had mentioned, that integration of radar is a big, massive step forward on the automation piece. So we're putting a lot of time, effort, and focus on that. And then again, we're continuing the development of the models for species identification. There's a pretty good data set and cross-reference of the number of species that you might encounter. And again, the tools and the tracking are not only to help intercept these species before they ever get anywhere near harm, but more importantly, also be able to count and track them for accurate understanding of everything from migratory patterns and movement to where the potential areas of concern might be, and really just, again, continue to have those improvements. So be happy to answer questions at the end, but to keep us on track, I'll pause it there.
Avastek, thank you. And coming online as well, it's going to be Kieran Boyd. And the topic of the presentation is intelligent robotic inspection, contact-based inspection using tethered flying robots. So take it away, Kieran.
Okay, great. Thank you for the opportunity and throwing this project together and everything. CRIN, it's been great to see the other projects working and in progress. We have a drone. It's quite a bit different from the last one, but our tethered flying robot performs contact-based inspection, like you said, on industrial assets. So I'll be going over the project objectives, progress to date, challenges encountered, and lessons learned to date, as well as the collaborative opportunities and our next steps. Our project objective is to take the problems tackled in the non-destructive testing space and provide the robotic solution. Conventional methods such as rope access and scaffolding endanger the safety and well-being of inspectors, as well as are time-consuming and expensive. With our tethered flying robot Skyron, inspectors can safely operate and stand in safe positions while decreasing the time and cost of inspections. Our progress to date has been working on our milestones. Largely our first one is come nearly there, which is our tethered flying robot Skyron. We've created it adaptable to different surfaces and using our fly, attach, and measure method, in which it flies to, attaches on the surface, and performs the measurement. So it's been able to do that on angled and curved, as well as piped surfaces. Our next is creating the advanced non-destructive testing, which is integrating the phased array UT transducer, and as well as the gauge integration and the phased array processing. Our third milestone is creating AI-based data analysis, which is a tracking and depth camera integration, detects the defects and C-scan defect detection. Our fourth milestone is our asset digitalization and visualization, in which we provide location tagging on the camera so inspectors can see where on a 3D map the locations are that they attach to. And our final is the industrial campaigns, in which we are pursuing 3 onshore and 1 offshore campaign. Along the way, there have been some challenges in the regulatory challenges of the oil and gas industry, and making sure our technology meets them in safety and proficiency. We have worked with them to find out what they are. The technical acceptance from the industry, the oil and gas and the non-destructive testing industry, has been a challenge in convincing people and showing people that our technology does work and it can help them. And lastly is the slow adoption of that industry. And though we have proven our technology, to some, it's not everybody. And so we have to work with the industry of accepting us. Along the way, the lessons we've learned have been the value and the close collaboration with clients. Understanding their unique requirements has helped us make and integrate custom solutions into our robot. Again, in getting to know the industry, we find our business offering of repeating and having them understand what we are is safer, faster, and more cost-efficient inspections. And lastly, although we are a new industry, we're not the only ones in this of creating flying robots for contact-based inspection. And it's essential for us to keep up to date in our standard, in meeting and exceeding those standards that are developing in this new industry. Our collaboration opportunities have been with many non-destructive testing and asset owners such as Shell, Dow, ExxonMobil, Imperial, and BP. We've worked in giving our product to non-destructive testing services such as Mistras, Oceaneering, Acuren, Sonomatic, and Belfinger. And the next steps for Avestec is to continue to develop our product and presence in countries we are in, which is Canada, US, and Indonesia. In this year, we have projects in Guyana and Brazil, and we are in communication for more projects of our robot in countries such as Netherlands, Germany, and Australia. And that's the presentation. Thank you for allowing me the time to speak about us.
And next is Viram. And I'm pleased to introduce, we have two speakers to bring us home, Trevor McMaster and Rob Southern from Viram Inc. And they will speak on their project titled Digital Twinning Legacy Facilities, Unified Data for Environment, Safety, and Productivity Improvements. And over to you, Trevor and Rob.
Excellent. Thank you, everyone. First of all, I want to thank CRIN for this, not only this cafe progress update, but for providing the framework just to bring these industry disruptive innovations to an outcome solution and eventually to a go-to-market. So really appreciate that. Just very quickly about Viram, we are also celebrating 10 years as a company this year, and we're based in Calgary. I'm very proud of that. But what we do is we provide visual, data-connected, rich digital twins to industrial asset owners, and we do that globally out of Calgary. And I'm actually coming from you today from our expansion office in Houston. And I do want to apologize. I'm joined by Rob Southern, our CTO. We're coming virtually today, but I'm proud to say we have two ambassadors joining you at the Energy Center today, Roy and Blaine. So please seek them out. We're going to talk about our project. As mentioned, we'll go through the same agenda as the previous presenters. But as you see in this infographic that we have here, really the problem statement that we're trying to solve in the industry is, if you look at the industrial asset profiles, over 90% of them are at least 10 years old, and over 80% of them have not been able to keep up with their 3D models, their CAD design, their as-builts, or even their isometrics. So there's a silo, or there is a scarcity of resources when you go to do asset management type of things. So really what we're doing with this project is, how do we close that gap on the information side? How do we get those aging assets that do not have up-to-date as-builts, and how do we give them the confidence to make asset management decisions? And that's all about bringing reality capture, asset information together in a connected digital twin. And really the benefits of this project is that business continuity when site access is either restricted or not available. We're seeing incredible productivity improvements when you bring all this information together that wasn't previously contextualized or aggregated. We're seeing worker productivity improvements. We're also giving the asset owners the ability or the option to go to site to confirm existing conditions. So that's leading to incredible reduced site exposure metrics that we're seeing. And again, less travel not only helps on the productivity side, but it also positively impacts the GHG side of things. And then the other really cool thing is once you have this reality model of your asset and it's connected to all your business systems, including your LDAR, your leak detection system, we're seeing efficiencies in that, efficiencies in notifications of events or notifications of potential risk, and then the remediation and mitigation of those. The one thing I do want to say is we are very lucky to have Imperial as our energy sponsor on this project. They've made both their Cold Lake and their Curl facilities available to us along this. And we've got some really cool solution partners, Alta ML and Revisions as well. Now, since Virum is all about that visual connected digital twin, and our tagline is work visually, reality first, I'm going to play a video that's been narrated by Rob to give you a little progress update. And I'll ask Rob, if you don't hear the sound, if you could do some ad hoc narrating. Appreciate it.
3D reality capture of industrial energy sites is now becoming the norm. The problem with this data is that any of the semantic objects at site cannot be automatically identified. So although this provides a great visual by doing these reality captures, you don't really understand what's actually out at site. So CRIN and Virum have solved this problem by training machine learning algorithms to be able to automatically identify what's at site and to tag that with a given class name and then attach it to business information systems. We can go up to the Virum search and search for everything with an AI performance metric. I can now drop in and see there was 12 pressure safety valves that were predicted within this imagery by our machine learning algorithms. For each of those, I can click on them on the left-hand side, and it'll zoom me directly to that particular pressure safety valve. I also have the ability at looking at any of the technical aspects of these predictions, including performance metrics. Within those performance metrics, I can also filter down to a specific performance score. So for example, if I wanted to look at a given confidence score that went above a certain threshold, I simply say, look for a confidence score that is above 20%. I can now filter down my predictions from the 12 that were found before to the 6 that are the most likely predicted objects within this particular reality scene. This also allows us to dig into various types of imagery while maintaining those same objects and predictions within those various visuals to be able to get in and do things like inspections in remote ways. Again, this makes it safer for the end users to never have to travel to site to be able to see these predictions. Thanks everyone for watching.
Thanks, everyone. I hope you enjoyed the video. In terms of our progress to date and where we are at, the CRIN scope of work was to really deliver on 4 object classes for object detection, and I'm very excited to say that we have done that. Our estimated completion is June 2023, and we do want to iterate on our AI ML predictions to make them a bit less noisy and a bit more accurate. You'll also see on the screen here, we have developed a split view ability so that you can see the predictions in your engineering drawings, such as your P&IDs, and then map those to the reality scans as well.
Some of the challenges that we're encountering along this project is the industry status quo that I just mentioned. Over 80% of the industrial assets out there do not have up-to-date CAD models or isometrics or other things to base asset management on. So this is an industry disruptive new solution where you focus in on the reality capture of your asset so that you get confidence in the existing site conditions itself. And the one quote I'll read here is from Matthew Bird, who's part of the Reality Capture Network, is it's not AI that will replace you, it's people and companies using AI that will. So once again, this project has given us the ability to leverage that new technology. Rob, over to you on lessons learned with the AI ML.
Yeah, thanks, Trevor. So I would say two kind of lessons learned from the more technical side. Obviously, AI ML modeling is an iterative process, but where the challenge is in that particular statement is that you might have certain clients or you might have certain internal expectations on how accurate those predictions need to be before you get that business value. And that's a really, really fine line to be able to figure out when we can start kind of pushing those predictions into that more production-based workflows. The other piece of this is since our training data is much larger and much more varied than expected, and much larger and more varied than what you would generally see in the computer vision space, it did make it tougher to actually train accurate predictions on the 3D object detection.
Collaboration opportunities. So any of those asset management, ESG focused type of sensor provider or solution providers, we would love to talk to you so you can plug in your system into our visual digital twin. And again, industrial asset owners who are looking to adopt digital twins and specifically ones that are focused around your reality capture would be great for us. The next steps, as you can see here, can you imagine an asset owner in a quick period of time at a lower cost be able to have a visually connected digital twin so that you have confidence on your existing conditions for asset management and projects? We're pleased that we're almost ready here to go to market, not only nationally, but internationally, and make a difference based on this CRIN project. So thank you.
So now is the fun part. You get to ask questions and engage in conversation with our 7 brilliant presenters. We will take questions from the audience in a minute, but we also encourage people who are logged in and watched online to type in your questions, and they will be monitored and read back here at the right time to all of us. So I could please invite our presenters to take a seat on the stage or the front of the room. And thank you, Monica Ling and Jack and Taryn. And online we have Jordan, Kieran, Trevor, and Rob. So that's 8 people to focus your questions on. So we'll start here in the audience. Anybody has questions? Apparently there's one over there. Oh, way over back there, Bob.
Mark, Dr. Bob Schultz, Haskell School of Business. And this is always an issue. You have the enthusiasm of where you're going to be, and you have the pessimism of where your customer wants you to be. Some of the things we just covered here. So how do you balance off trying to pitch your products about where they are to the next company when you aren't done with the one that you're with?
Awesome. And I think that's addressed to everyone. It's so we'll start from, Ling, go ahead.
Yeah, good question. It's always about listening to your customer and really getting the operator feedback, talking to the folks in the field about how they use their technology, and just really it's an iterative process. I think your business model always you have to be flexible and listen to your customer, and just keep innovating that way.
For our technology, that's a really great question. It's actually one of our differentiators compared to the products that's available on the market. We are target to be a customized solution in terms of the AI part. So the machine learning part, in the opposite, we are trying to generalize that to be a more generalized tool by what we presented, working with the manufacturer companies and working with the OEMs and also the operators for sure.
All right. So short-term and long-term goals, very important to keep in mind. Working with customers closely, short cycles, get feedback very, very fast. Always remember what the strategic vision is and how the requests, fit in that overall vision. But yeah, it's all about customers, for us.
Yeah, I would reiterate that just that feedback loop from some of our early adopters and clients has been really key for us to advance and get better, and then use that learning to move to additional clients. We're not dropping the existing ones. We're just trying to learn and having that collaborative process where there's cross-functional conversations and learnings that really helps us to develop and grow and get better and provide a better product to existing and future clients as well.
Yeah, thank you, Taryn. And we'll go online to Jordan.
Yeah, I think from our perspective, the biggest aspect on that is exactly that same piece. You want to make sure that what you're developing is actually making lives easier. And then you want to take that iterative change and apply it to the next client and the next client after that. But Bob, I don't think it's a matter of moving on to the next client. It's making that entire ecosystem. Your first few users are really your most important allies, and they'll end up being your best advocates too. So the more you make their lives easy, the better it's going to be in the long run.
Thank you, Jordan. And Kieran?
Yeah, I couldn't agree more with Jordan in that regard of having the first few clients or any clients at all request their changes or what they need, and taking that technology with you and building on that, repeating that pattern. If I were to take one more thing out of what we've learned, is that the problems are continuous, and I think a lot of people can approach them from different places. And so you just have to get a real thorough understanding of where the client is coming from and share with them what you have.
Thank you. And Trevor or Rob?
Yeah, I'll weigh in first, but I couldn't agree more with the panelists there. At Virum, we do a lot of market discovery. We ensure we know what the industry problem is out there. We know what the solution outcome expectations are. And then we work with our customers in developing that solution. And it's iterative too. We test it out. And at the end of the day, our global domination strategy is to get those first few reference customers like Imperial. And they'll land and they'll expand us. Nothing better grows a company and their solution than reference customers. So Imperial has already taken us to ExxonMobil, their parent. ExxonMobil is already taking us to industry. So Rob, anything else to add?
Yeah, I would just add from the technology or the product side, our clients are very aware of the problem that was described in the question, and they don't want us building one-off custom solutions because they know that's not sustainable. And they've really matured to the point where they really look to work with us to build those repeatable solutions that apply to the wider market. So I applaud our technology partners and our clients for that insight.
Good point. And Bob, what's the grade? They got A+, all of them? On their way. Okay. Okay, perfect. Question at the back here. Sorry, maybe there was another one I missed.
Hi, I've listened to everybody today, and what I'd like to hear is what's your main differentiator in your business that you offer versus what other companies offer? Is it low cost? Is it strategy? Is it quality? What is that?
Thank you for the question. And I guess we can go through the rotation and start with Monica, well, Taryn has the mic, so let's go start with Taryn.
All right, great question. Thank you. With Qube Technologies, one of our differentiators is truly being a low-cost continuous monitoring solution that can scale. We know that this is a widespread issue with emissions. Emissions can happen anywhere, and having the ability to deploy these devices at scale in a quick manner and have low operational what's the word I'm looking for? Sorry, that low effort to get these up and running for quick wins is a big thing. And also just the data science piece, we're really working on building our models to have that localization and quantification piece really dialed in, really accurate. That provides a robust solution for operators to really trust the data that's coming in.
Thank you.
Thank you. As for SensorUp, it's, I think, all about the data. We work with customers who have collected over time a lot of information from various sources. That information is not enriched, not combined together. Relationships, don't exist. So what we do is we aggregate all the data, connect the data, absorb it, push it into our system, and then make the data work for customers. So that's what we call ourselves data fabric, and we really do that.
Great question. Thank you. For VL Energy, I think our differentiator is we have something that we are comparing to prove our accuracy. So as I mentioned, we are a regulatory compliance tool that is very mature. So our data or the result or the model result that we are comparing to has a standard that's very mature from 20 years ago. So we know what's good data quality, what's not, and what's a good result or not. Thank you.
Yeah, thank you. So with Kuva systems, I think there's a few components. One is that we are a low cost, visual continuous monitoring, as well as providing no false positives. So low cost is important because we need to, methane emissions detection is a cost center for our customers. So it needs to be something that's affordable. Secondly, in terms of addressing the visual piece, you need to see it to solve it. A picture is worth 1,000 words. And that when you're able to see a picture of the scene and then get down to the component level of where that emission is happening, then that just speeds up everything in terms of being able to mitigate your emissions. And then lastly, in terms of no false positives, we're providing that right now, and we're further automating that exactly with this CRIN project. So we're grateful for the support of CRIN to be able to help support that.
Thanks, Monica. And we'll go online. What's the key differentiator, Jordan, for Arium?
Well, we have a pretty key differentiator in our technology that we're one of the only flapping wing drones on the market that's actually usable. But in addition to that, we're really focused on that wildlife environmental protection, being able to help protect biodiversity while decreasing greenhouse gas emissions and keeping people safe. So it's really tying into ESG, but looking at using nature and what it does best in the technologies as we move forward.
Awesome. And Kieran?
From a technology standpoint and flying robots for inspection, we have our attached arm that differentiates some of the other products in the space, as well as a smart tether system, which provides unlimited flight. From an approach standpoint, I think to the business and the market, we've had experience in which we provided the service, and that has helped us understand what the product needs to be in direct relation to the needs of the service and the end clients.
Awesome. And then Viram, Trevor, and Rob, what differentiates you with your customers?
I'll go first there, Rob. So it's definitely time to value. As I mentioned before, the current status quo for industrial asset owners is to do what's called scan to BIM. So they take a reality scan of their asset, they give it to a engineering services company, and then they'll model their 3D model type of thing. What we do is focus on that initial reality scan, and we make sure that's connected. So really what we do is reduce the cost of getting to that intelligent digital twin by about 80%. And most importantly, we reduce the time. The time is cut by about 75% on average. And we support that work and operate from anywhere type of thing with a visual digital twin. Rob?
Yeah, I would say on the technology side, we have tailored all of our technology into specific capabilities for delivering client persona-based outcomes, meaning that we dig into how are you going to do maintenance planning remotely, safely, securely, and more efficiently. And we make sure that all of our user experiences and all of our technology is built around that specific tailored outcome for those given personas. And that's allowed us to win in the market and will continue to let us win.
Wow. So 2 questions, 8 answers. We will want just a quick check online if there are questions. No questions online. We're at time for the webinar portion, and I want to thank all of you for making the walk over to the ETC. Nice to see everyone in person. We have coffee and baked goods, as I mentioned, for networking part of this the in-person side of the event. So thank you all online. Thank you, our presenters. Thank you to CRIN. And yeah, the webinar is coming to closure. Thank you.